Heyo, it's Mrs. Weekly. So, we are moving on into some different kinds of word problems for applying systems of equations. If you were on the Google Meet yesterday, I kind of gave you a heads up that we were working out of our book. And you will also have homework that will be worth a smaller grade today as well. So, if you want to pause real quick and get your book out and get something to write with, we are going to be on page 388. I also put it right here on every page so you know what page it's on. I recommend getting it out because I literally took a picture and just put it in this, so it's not the best quality. I'm going to take some time to go through these examples. There are 3 of them that I want to go through, and then I will post your assignment on Classroom for you to complete. So, let's start. So, problem number 1 is talking about finding a break-even point. All right, so in this case, you have a fashion designer that makes and sells hats. So, material for each hat costs the $5.50. Okay, so the hats sell for $12.50 each. The designer spends the $1,400 on advertising. How many hats must the designer sell to break even? Okay, so you're going to do the same process as you do with any other applying systems kind of problem. So, first step is to define your variable. Okay, you can see that in their first step, they also did that. Ooh, excuse me. So we're going to stick with what they have. So, again, we're defining what X is and what Y is. So, keep in mind it's asking how many hats must the designer sell to break even. Okay, so I'm going to say X is the number of hats they sell. Okay, so that's definitely my unknown. So hats sold. Okay, and if I'm breaking even, you're kind of thinking about like, okay, I'm selling so many and I am spending so much. So basically, when those are equal to each other, you're going to break even, okay? Because once you're kind of past that point, you're making a profit, okay? You're making money on your investment there. So that leaves Y with a number of dollars. Okay, so let's think about this. So Y is just basically how much money they spent or are making, okay? So for the first equation, so that's just the total number of money. So Y is equal to, so I'm going back up to the top. So material for each hat costs $5.50. Okay, so I'm talking about how much things are costing, how much they've already spent, not what they're earning. And then it says it sells for $12.50 each. Well, those are 2 separate things. One, they're making money because they're selling it, and one, they're spending money in order to make it. So the $5.50 and $12.50 cannot be part of the same equation. The next part says the designer spends $1,400 on advertising. Well, that's spending, right? That's like investing money. So I need anything that they're spending. So they're spending $5.50 for materials and $1,400 for advertising. So that's going to be part of the same equation. So it's going to be $5.50 for each hat. Well, X is my hat, so that's $5.50X. And then plus that $1,400. Okay, so that's the combined amount of money that they're spending for making these hats. Then next equation, so you have Y equals, which again is just the total number of money. But in this case, we're talking about how much they're making, right? How much they're selling it for. And they're selling it for $12.50 each. And there's nothing else that they're selling or charging. So $12.50 per hat, and again, X is hats, is going to be my next equation. So now that I have defined my variables, written my equations, I can go ahead and use substitution in this case. It's going to be the easiest method. So I know that Y is equivalent to 1250X, so I can just substitute that in there. And I'm going to have the 12.5x equals 5.5x plus the 1400. 1400. And I can subtract 5.5x, subtract 5.5x. That's going to leave me with 7x equals 1400. Divide each side by 7. I'm running out of room. Coming over here. X should be equal to what, 200? Okay. So X again is number of hats sold. What was it asking? It says how many hats must the designer sell to break even? Okay, so the break even, here's how to kind of think about this. Here's why I chose to do this. So this was how much they spent, right? Or sorry, this is how much they sold, was the 1250X. That's what this represented. And I set that equal to how much they spent. So when those are set equal to each other, you're going to break even, right? You're not making any money, but you're not losing any money. You're even. So once these are set equal to each other, I can figure out how many hats were sold. And there should have been 200 hats sold in order to break even. Okay? If you want to pause now and do the got it, you'll have to go out of your book because obviously you can't see it all right here. And I pause it, I will tell you the answer. It is 720 books for that got it. All right. If you needed help with that got it, just send me a text or an email and I will gladly help you. All right, moving on to the next one. So again, this one is on page 388. This one is talking about, okay, since we're dealing with real world situations, sometimes there are going to be solutions that are not possible. So I think you can probably tell that this is going to be an example of one, but let's see why. All right, so again, we're following the same steps. Define your variables, make your equations, and then solve. So the local zoo is filling 2 water tanks for the elephant exhibit. One water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank contains 29 gallons of water and is filled at a constant rate of 3 gallons per hour. When will the 2 tanks have the same amount of water? Okay, so I want to know when they're going to have the same amount of water. So if they're going to be the same, that's kind of like a break even type of thing, where tank 1 is going to be the same as tank 2. They're going to be set equal to each other. So now I got to think about, all right, my variables. So X and Y. And with these, so the problems that you had yesterday and the day before, I think it was a lot easier to tell what X and Y is to start out with. If you can't tell right away, that's okay. Just make sure that you come back to what X is and what Y is, and make sure that you define those so they're clear when you go to answer your final question. So we're going to go ahead and define them. Again, if you're not quite sure right now, that's okay. But it's asking when will the tanks be the same amount of water. Okay, so when tells me how much time, right? So we're talking about, notice they said like gallons per hour before. So wait, I know that I'm going to be working in hours, okay? So this is going to be the number of hours for X. And my Y value, if I'm thinking about kind of the situation at hand, there are tanks with a certain amount of water, but it only tells us how much it's filling up per hour and how much was originally in it. It doesn't tell us the total amount. So that's another unknown. So that is going to be, I'm going to say gallons because it mentioned gallons again, and tank. Okay, so now I'm moving on to my 2 equations. And again, I'm thinking, okay, there's like 2 situations going on. So I have 2 equations. Tank 1 would be one situation, and tank 2 would be the other situation. So tank 1, so the Y would be like the total number of gallons. So Y is equal to, so I'm going to go with tank 1. So it says 1 water tank contains 50 gallons. So that 50 gallons isn't changing. Okay, so that's a constant. So that plus 50, I'm going to add here. And then it says it's filled at a constant rate. Well, a constant rate means it's going per hour, right? It says 10 gallons per hour there. So that's 10 gallons for every single hour, but we don't know the number of hours. So that's why it's 10x, because x is representing whatever number of hours. So tank 1 is done. Tank 2. So again, Y is like the total number of gallons in the tank. So the second water tank, it tells us, contains 29 gallons of water. Again, that's not changing. That's just a flat 29 that it started with. And then it's adding so many per hour. So I'm going to add that 29 here first. And then this one's going at a constant rate of 3 gallons per hour. So that's 3x because x again is the hours. Okay, so now that I have my two tanks represented, I can see when those tanks are going to have the same amount of water. So at this point, I'm going to have you pause and go ahead and solve. Okay, so again, I would probably choose substitution. So pause and solve real quick. All right, so when you solved, all I did right now was solve for x. So I set them equal to each other up here. Okay, so those two tanks are equal to each other with substitution. I kept in mind that x is the number of hours and y is the number of gallons in the tank. And I'm getting x to be -3. Okay, so even just thinking about this, if I weren't sure if I did it correctly, I would obviously go on and solve for y. So I could take one of my original equations and say y equals 10 times -3 plus 50 and go ahead and solve. So y would be that would be -30, add that would be 20. So when I get y equals 20, it's basically telling me, so if I'm looking at what x represents and what y represents, x is saying, so like at -3 hours, the tanks will both be at 20 gallons. Obviously, -3 hours is not going to be an option. So in this case, there would just be no solution. Okay, so even though you're getting an x and a y value, but according to the real world kind of situation, we can't have -3 hours. So there is going to be no solution for this particular question. All right, so if you wanted to do that got it number 2, I forgot to say what the answer was to that. So if you want to do got it number 2, it's actually on page 389. And the solution to that would have given you the ordered pair -214. But it's not going to be a viable solution. Okay, so it's not going to be possible. They're never going to have the same amount of water. Okay, so moving on to problem number 3. Okay, so this one is dealing with like wind or current. This particular one deals with wind. So it's telling you a traveler flies from Charlotte, North Carolina to Los Angeles, California. At the same time, another traveler flies from LA to Charlotte. The airspeed of each plane is the same. The ground speeds are shown below. What is the airspeed? What is the wind speed? Okay, well, same process. I'm going to go ahead and define my variables. So I know a lot of times we use x and y, but we're probably going to get into now, you're a little more comfortable with it. I'm going to use a and w. And this one's a little bit easier because when I define my variables, it's asking for two different things, telling me what my two unknowns are. So airspeed, I'm going to use obviously a. And wind speed as w. Okay, so those are obviously my two variables that I'm looking for. Now I have to go create my equations. So using the information that they kind of give you in this little diagram, it's telling you the ground speeds. Okay, so that's just saying like if we're on ground, this is how fast we'd be going. Okay, so when I'm doing this, so you basically have one person starting here, going here, and then the other person doing the exact opposite. So starting in LA and moving to this side. Okay, so they're going the same distance, but they're moving at different speeds because of the wind that is either going against them or going with them. Okay, so if you ever like ran against the wind, it takes a little more effort, right? You're probably going just a hair slower than what you would be if you are going like running with the wind and it's like pushing you. Okay, so that's the same kind of thing here. So when I'm thinking about it, you can see the wind and it's moving. It's that red arrow. Let me erase my arrows. It's that red arrow and it's moving from left to right. Okay, so from the west to the east coast. So that's the wind. So we have to determine if we're going against the wind or going with the wind. So when I'm looking at this kind of problem, the airspeed is telling me, okay, I have the airspeed. I'm going to go from Los Angeles first to Charlotte. That's going to be the first one I'm looking at. So if I'm moving from Los Angeles to Charlotte, I'll make it blue. Am I moving with the wind or against the wind? I'm moving with the wind. So the airspeed is going to be combined with the wind speed to be equal to what? It looks like this person is moving 550. So that's what equals the ground speed. Okay, so the airspeed plus what the wind is giving it tells you how fast it's going altogether, which is the ground speed. So now I'm thinking the opposite way for my other equation. Okay, so second situation, I'm dealing with, I'm going to use green. I'm starting at Charlotte and I'm moving to Los Angeles. So I'm going against the wind at this case. So it's the airspeed minus the wind since I'm going against it. And that's going to be the ground speed of, what's it telling me? 495? Okay, so now at this point, I'm going to think about how I can solve. So I have my two equations. And in my mind, I'm thinking, okay, elimination's probably my best bet. So when I go to use elimination, I notice that my W terms are going to cancel if I add this entire equation, so that's what I'm going to do. So when I go to add, A plus A gives me 2A. W plus a negative W is going to cancel or eliminate. And then 550 plus 495 is going to give me 1045, I believe. At this point, I have just a one-step equation. Excuse me. I can divide by 2, giving me the airspeed of whatever that is divided by 2. 45 divided by 2. So 522 and a half. Okay, so I've answered part of the problem so far, but I also need to figure out what the wind speed is. Since it asked 2 questions, I need to have 2 answers. Another thing that I need to keep in mind, the label here was talking about miles per hour. So that's saying like the airspeed is in miles per hour as well. Okay. Next, I need to solve for W. So I can go back to either one of my original equations that I created and just substitute in. So if I choose this top equation here, instead of A, I'm going to type in the 522.5 plus W equals 550. If I subtract 522.5, subtract 522.5, at this point, when I solve, W is going to be equal to the 27 and a half. And again, that's miles per hour. So I'm going to put MPH here. Don't forget to label. I know mine's a little sloppy, but just don't forget to label that miles per hour. Okay. So at this point, again, I could substitute in A and W into both of the equations and make sure that it actually works out. As long as I've answered both of them, I can say, okay, the wind speed is 27.5 miles per hour and the airspeed is 522.5 miles per hour. And that is it on this one. If you want to try the got it, go ahead and flip the page. The got it's at the top. Letter A, you don't have to do letter B. If you're doing letter A, the answer is, pause if you want to do it real quick. Letter A's got it is, for the first question, it asks the speed of still water, and that is, I believe that one is the the 1.5 miles per hour. And the speed of the current is 3.5 miles per hour. I could have them flip flop because they don't have them labeled here. And I didn't honestly work it out right now. So one of them's 3.5 miles per hour and one of them's 1.5 miles per hour. If you have questions about that and you don't quite understand that, obviously contact me and I will help you with that, okay? All right. Use these examples as kind of your go-to. If you have questions, obviously email me, text me. I'm here for you. Let me know if you have any questions. See ya.